A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. I welcome you all in our today's online lecture of instrumentation and measurement. Hope you all are fine and having good health. We start today's session with the verses of Holy Quran. So today's session is about lecture number 3 and measurement. So in this slide you can see these are the number of analog and digital measuring instruments which mainly use in electrical to measure electrical as well as mechanical parameters, and some of the physical entities can also be measured by these kind of meters. So these are meters are voltmeter, ammeter, frequency meter, pressure meter, temperature meter, which can measure the particular or respective entities, digital as well as the analog. So coming towards the content of today's session is static characteristics of instruments, and static characteristics are given in the data sheet of particular instrument that we're going to measure the particular entity. Static characteristics which are based on the accuracy, sensitivity, linearity, and as well as the reaction to ambient temperature change. And what are these things? Accuracy is related to the measurement criteria by which it is up to the mark as per the requirement of a standard. Sensitivity, that how much accurately it provide, how much accurately it sense that particular medium which we're going to need measure at that instant. Further coming towards the linearity concept, linear is that the entity, if it's major, reading also be increasing in linear way. And what is the non-linear? The opposition effect of non-linear, that input is going to be high and output is downward direction. So we can say it's a non-linear behavior of a measuring instrument. Further reaction to ambient temperature changes means, and what is comes to the concept of ambient temperature. Ambient temperature is the kind of regular or normal temperature of a particular device which it is working on a nominal ways or behave linearity. That particular temperature is called ambient temperature. So there is a difference between normal temperature and ambient temperature. Normal temperature is relativistic to the human, relativistic to the uh, laboratory, but the ambient temperature is related to the particular device. These characteristics only apply when instrument is used under specified standard calibration conditions. Due to allowance must be made for variations in the characteristics when the instrument is used in other conditions. So comes to the topic, that is the accuracy. So the accuracy of an instrument is a measurement of how close the output reading of the instrument is to the corrected value, user defined value, well defined value, or the value which required. So accuracy is that more usual to quote an accuracy figure rather than accuracy figure. So we most usually prefer the accurate figure as well as its requirement by the user. The term measurement uncertainty frequently used in place of inaccuracy. So in these kind of four cases, you can see all the dot of marks are in the position of poor precision and poor accuracy because all are in different points. But in case number 2, you can see the precision is going to be the good in this point because all the points are pointed on a single patch which can be made in the site. But it have the poor accuracy. Why? Because it should be near to that center point. That particular condition we can say it will be a good accuracy. But now in this case number 2, it is the poor accuracy. Now we moving further towards the concept of poor precision. So why poor precision? Because most of the dots are diverged from the center point. They are not converging toward this one, but good accuracy can be shown by their it is converging into a center point. It is called the good accuracy because it is towards the center point, desired point. But poor precision means all the points are diverging positions, different positions. They are not close enough to each other. That's the reason it is the poor precision. Now coming towards the case number 4, that is the good precision and good accuracy because all the dot points are uh, placed on a center point as well as they are converging towards a single point of convergence. That's the reason in case number 4 out of 3 it achieved the poor precision as well as the good precision and good accuracy. Now further accuracy, how much it relate to the required output. Inaccuracy is the extent to which a reading might be wrong and often quoted as a percentage of the full scale reading of an instrument. If for example, the pressure gauge of range 0 to 10 bar has inaccuracy, that would be mentioned in coming figure of plus minus 1% of tolerance level. So full scale deflection plus minus 1% reading of 1% would be, then the maximum error to be expected 0.1 out of the without percentage value would be 0.1 of the error value. However, if we were measuring pressure with expected values between 0 to 1 bar, we would not be using this instrument. If we need to use the accuracy of the range of span between 0 to 1, then the error of sampling of full scale would be 0.1, which can emphasize towards the error. So at the range of 0 to 1, 0.1 bar of error cannot be acceptable in this case. So we need to use that particular range of value which have less number of full scale error tolerance, which means it should be very less at the range of 0 to 1. But if we have the range of 0 to 10 bar, then this value of 0.1 would be negligible for 0 to 10 bar of range. Before we would like to be using the instrument with range 0 to 10 bar, as the error 0.1 bar makes 10% error for this case, which is a bigger. It is an important system design rule that the instrument is chosen such that its range is appropriate to the spread of values. Now coming towards the next concept, it's precision, repeatability, and reproducibility. Precision is a term that describes an instrument degree of freedom from random errors. If a large number of readings of same quantity are taken by a high precision instrument, if we have a high precision instrument and we take multiple time reading of a same scenario, then the spread of reading will be very small. So the divergent or the deviation in measuring the reading, it would be very small. Precision is often through incorrectly confused with accuracy. So most of the time we merge the concept of precision and accuracy, but they are two different kind of concepts. High precision instrument may have low accuracy. So this can be done because we can see that if the precision is high, accuracy can be poor. So this is the third statement reflect on this diagram. So further coming towards the repeatability and reproducibility. Repeatability describes the closeness of output reading when the same input is applied repeatability over a short period of time. With the same measurement conditions, some instrument and observer, same location and same conditions of use maintained throughout. So repeatability, if a single person do the concept uh, uh, multiple time with the same values, then the repeatability values in sense of parameters, then repeatability can be fulfilled by that particular instruments. But reproducibility is something different. Reproducibility describes a closeness of output reading if we multiple time repeat the concept. So reproducibility would be can be fulfilled. Reading of the same input when there are changes in the method of measurement. If you perform the experiment but with different method, then the observer, measuring instrument, location, condition, these are the things which going to be change of use and the time of measurement. These are the variation if you can fulfill, then the reproducibility can be fulfilled. After reproducibility, we coming towards the precision, repeatability, and reproducibility. Repeatability and reproducibility describes a spread of output readings for the same input. Repeatability for constant measurement conditions, and reproducibility is for varying measurement conditions. So constant measurement condition can provide the repeatability, and the varying measurement conditions can provide the reproducibility because there is a variation in conditions and measuring condition as well. The reproducibility and repeatability is an alternative way of expressing the precision. So precision can be expressed in different ways in sense of repeatability and reproducibility. So this is the same scenario which we are going to discuss in our previous slide in case of 1, 2, 3, and 4. Now coming toward the concept of tolerance. Accuracy of some instruments are sometimes quoted as tolerance figure. So accuracy, that how much accurate that vernier caliper, a screw gauge, and can provide the value in sense of less accurate or more accurate value. For example, 1000-watt resistor having 5% tolerance might have an actual value anywhere between 950 watt to 1050 watt. This is the range of span can be happened by the tolerance value of variation 5% of 1000 watt of resistance. अब अगर हम एक इस्तेमाल कर रहे हो एक डिवाइस जिसकी अपनी रेजिस्टेंस 1000 वाट की है और उसकी टॉलरेंस वैल्यू 5% है, तो वो अपने अंदर वेरिएशन कम या ज़्यादा भी कर सकता है, यानी वो 50 जो है वाट कम भी कर सकता है और 50 वाट बढ़ा भी सकता है 1000 वाट के मुकाबले में, बिकॉज ऑफ इट्स टॉलरेंस वैल्यू, बिकॉज ऑफ एक्यूरेसी. So coming towards the next concept, that is the range or span. Range is the starting ending values in which between the scale of values can be lie. The range or span it can also be represented span and can be said as range. The range or span of instrument defines the minimum or maximum values of a quantity that the instrument is designed to measure. So that range is difference between the greatest and smallest value. So further coming towards the linearity, it is normal desirable that the output reading of an instrument is linearly proportional to the quantity being measured. The blue line in this graph shows the linear characteristics because the linearity can be fulfilled happening in this point of line direction. So displacement versus voltage can be increasing linear way. When the displacement is increased, then voltages would also be increased according to this linear graph. The x of x marks on the following figure shows a plot of typical output reading of an instrument when a sequence of input quantities are applied. That mark of excess like this one. The nonlinearity is defined as the maximum deviation, divergent deviation, bikharna unka, of any of the output reading mark x from this straight line. Nonlinearity is usually expressed as percentage of full scale reading. So nonlinear behavior can be happened, and in nonlinear behavior, uh, the particular graph can be varied with nonlinearity. So in the graph, which is the major quantity versus output reading, can shows the point are divergent in different location or positions. So sensitivity of measurement is related with or equal to the gradient. So if we draw a regression line, then less number of points are lied or touch these points. So there is a slight variation of the reading, and it behaves like non-linearity. Now we further moving towards the next concept is sensitivity of measurement. अगर हम कोई चीज़ मेजर कर रहे हो तो वो कितनी हसास तरीके से वो वैल्यू दे सकती है, ये मैटर करता है. फर्दर मेजरमेंट में जो हसासियत एक टूल ऑफ मेजरमेंट की होती है वो बहुत मैटर करती है, क्योंकि जो इंस्ट्रूमेंट ज़्यादा हसास तरीके से सेंस करके रीडिंग महसूस करके प्रोवाइड करेगा वो ज़्यादा एक्यूरेट होगा. दैट्स अ रीज़न more sensitive is a good instrument, but the less sensitive is bad instrument in instrumentation or measurement criteria. The sensitivity of measurement is a measure of change in instrument output that occurs when the quantity being measured changes by a given amount. So sensitivity is a ratio of scale deflection over value of measured producing deflection. So this ratio is called sensitivity ratio of a particular tool. So you can see these are 1, 2, 3 large numbers are the centimeter of a scale, and in between the intervals are the millimeters, that 1 millimeter, 2 millimeter, 3 millimeter, 4, 5. Towards the 10 centimeter, 10 millimeter would become the 1 centimeter. Onwards, this is continue in the same way. So more accuracy can be fulfilled in a small scale of millimeter as compared to the centimeter. This shows the sensitivity or accuracy which can be reflected by that particular instrument during measurement. Sensitivity of measurement. So the sensitivity of measurement is therefore the slope of the straight line drawn on producing figure. If, for example, a pressure of 2 bar produces a deflection of 10 degree in a pressure transducer, the sensitivity of the instrument is 5 degrees per bar. So how can we find this? By this scenario, which you can see in example 2.1, the following resistance values of a platinum resistance thermometer were measured at the range of temperature. Determine the measurement sensitivity of the instrument in ohms per degree centigrade. So a temperature sensing device, we can say it's a thermometer, can sensing a temperature which is increasing by 200 towards 290 degree. At the same instant, the resistance is also respectively going from 307 to 328 from this direction and also from this direction. So if you want to find the sensitivity of the instrument ohm per centigrade, then if these values are plotted on a graph, the straight line relationship between resistance change and temperature change is obvious. If the temperature would be increased, then resistance can also be increased. This is the same criteria in RTD, resistance temperature detector. For the change in temperature of 30 degrees, the change in resistance is 7 degrees. Every instant, 7 ohms would be increased by increasing the temperature from 230 degree, 200, 230, 260, 290. These are the increasing variation is 30, 30, 30, and here is 777. So that how can we find the sensitivity? That divide that particular value of resistance of sample gap with temperature sample gap, which is a 30, and 7 divided by 30 becomes 0.233 ohm per centigrade. This would be the value of sensitivity of RTD, which is measure the resistance value by sensing temperature. Now we further moving towards the threshold value. If input to an instrument is gradually increased from 0, the input will have to reach a certain minimum level before the change in the instrument output reading is of a large enough magnitude to be detectable. This minimum level of input is known as threshold of instrument. From after that point, device can be workable and provide its reading. Manufacturers vary in the way that they specify threshold for instruments. In manufacturer or vendor books, it is completely mentioned the value of threshold in a particular data sheets and in their logbooks. Some manufacturers quote absolute values, whereas other quote threshold as a percentage of full scale reading. So in some of the chart, in some of the tables, in some of the booklets, it represent the threshold values and full scale value in the sense of percentage. All an illustration, a car speedometer typically has a threshold of about 15 km per hour. So that threshold can be crossed, then after that point, conduction or linearity would be in linear way. This means that if the vehicle starts from rest and accelerates, no output reading is observed on the speedometer until the speed reaches 15 kilometers. So after 15 kilometers, it is start providing its accurate reading or values. Now coming towards the next concept, that is the resolution, digital versus analog devices. How finally an instrument output is divided into subdivisions. For example, the thermometer will have a resolution of 0.05 degree centigrade. Sensor will have sensitivity, whereas meter will have a resolution. Thermocouple, which is the sensor, have sensitivity 4 volt per centigrade. degree centigrade, but thermometer, which is the meter, have a resolution of 0.05 degree centigrade. So this is the sensitivity in sense of thermometer. Now sensitivity to disturbance. So how sensitivity can be caused to disturbance? So this concept of sensitivity to disturbance, we can continue from the next lecture. So see you till the next session. Allah Hafiz from my side.